My name is Michiel. I'm project manager here at The Switch. And I want to talk to you a little bit about our permanent magnet generators for marine applications. So before we go into the generators themselves, I take one moment to explain a little bit more the difference between our permanent magnet technology and the conventional rotor technology. So with our machines, we always use permanent magnets. The reason for that is that it's much simpler to design and much simpler to keep the permanent magnet field active. Traditionally, in the generators designs you have in the conventional generators, this kind of winding system on the rotor, and we don't use that at all. We don't need that. We keep our design simple and rugged. There's many advantages because of this. So for example, comparing conventional rotors to permanent magnet rotors, we have almost no magnet losses over the whole lifetime of the machine. Also, the design of the rotors is much simpler, so you don't need any of these additional components like slip rings, exciters, the windings themselves, and so on. You save space because the permanent magnet rotor allows for a smaller machine design, and also improved drivetrain dynamics because of the reduced mass and rotor inertia. Here we see a short efficiency comparison between typical inline shaft generators. When we look at the red line, we see the permanent magnet generator efficiency curve, and then the blue one is the conventional synchronous generator. We can see quite clearly that there is an efficiency difference, an advantage with permanent magnet technology compared to conventional technology over the entire output power range of the machines. So this is what we have to offer for you. We have at the moment 3 different sizes: PMM 1000, 1500 and 2000 sizes. PMM stands for permanent magnet machine, 1000 is the shaft height in millimeters, and M stands for marine. We provide these machines over different speed ranges and depending on your power applications and torque applications. So these are the 3 options that we can choose from, and then we can play a little bit with the different lengths, stack lengths, for example, of the machines to get the required power for your application. The big one, for example, goes up to 12 megawatts at the moment. So these are quite powerful machines. Here you see a short overview or a picture of the inline PM shaft generator system, what it looks like. So we are literally talking about putting our machine on the same shaft line behind the motor or behind the main diesel engine on the propeller line. And then the converter cabinets can be located even elsewhere on the ship. They don't have to be in the main engine room. The benefits of the inline permanent magnet shaft generator comes down to 3 things: reduced fuel consumption, reduced emissions, and reduced maintenance costs. All of these come down basically to the advantages of the permanent magnet technology and the location of the machine on the vessel. So with this kind of a design, with this kind of a machine, you can keep your auxiliary gensets off most of the time. When the vessel is sailing, the shaft generator is providing all the power you need. Because of this, you have reduced fuel consumption. And because of this also being the permanent magnet technology and better efficiency, you reduce there the costs on your fuel and lifetime savings. Possibility for boosting and load leveling to optimize the main engine design and also there reduce fuel consumption. And one nice advantage also with the permanent magnet technology is there's no wearing parts really inside the machine. So there's also reduced maintenance costs. Here's a bit of an overview of the different components of the machine if you're interested in this in more detail. So the main design of the machine itself, we have the stator structure with the rotor inside. The cooling unit is on top. We use water to air heat exchangers, cooling fan motors to circulate the cooling air inside the machines. We have the terminal boxes on the side of the machines, alternatively also on the front end of the machine, depending on space requirements on the vessel. And then we have a bunch of other sensors, equipment, optional things that whatever the customer is interested in having in the machine, we can discuss and provide those. The permanent magnet machines can also be used for direct drive propulsion. So right now I've just been talking about generators, but they can also be used as motors. It's a very simple design because you don't need a gearbox. And because of the permanent magnet technology, you have the much smaller footprint on board the vessel. Then again, we come to the high efficiency, even at the, or especially at the partial loads. And because of this simple system, there's low vibration noise. So it's ideal for the structure-borne noise critical systems such as fishing or research vessels. Here's an efficiency curve to show a little bit the direct drive propulsion efficiency. So you see quite clearly that the efficiency of the machine is pretty much stable, undependent on the speed of the machine itself. And this is the advantage of the permanent magnet technology. And as a last slide, just a little bit about what we have delivered so far. So right now we have already delivered over 250 permanent magnet machines, and with the cumulative power of over 24,000 megawatts. That's the end of the presentation from me. So if you have any questions or if you want to discuss with us about permanent magnet machines or our technology, please come stop by our booth and talk to our experts. Thank you.